I've been hearing a lot about how data is the backbone of machine learning. Can you explain why data is so important for building these models?
Absolutely. Data is fundamental because machine learning models learn patterns from data. They can't understand the underlying complexity of the real world if the data they use is noisy, biased, or unrepresentative. In short, data serves as the raw material for machine learning models. If it's bad, your results will be bad.
So, what makes data high quality? Is it just about having lots of data?
Not necessarily. High-quality data is about relevance, accuracy, and consistency. It needs to be clean, relevant to the problem you're solving, and unbiased. Having lots of data doesn't matter if it's not representative of the problem you're trying to solve. For example, if you're building a model to predict customer behavior, you want data that's relevant to customer interactions, not random sensor data.
I see. What are the different types of data we typically work with in machine learning?
There are several types of data we deal with. You have structured data, like numbers and text in databases, unstructured data, like images, audio, or videos, and semi-structured data, like data in logs or social media posts. Each type has its own challenges and pre-processing steps.
How does data pre-processing fit into all of this?
Pre-processing is essential because raw data rarely comes in a format that a machine learning algorithm can use directly. You might need to clean missing values, normalize numerical data, or vectorize text for NLP models. Pre-processing prepares the data for algorithms to process and learn from it effectively.
What are some common issues with data that you have to address in ML projects?
There are a few common data issues you'll come across, like missing values, duplicates, outliers, data drift, and noise. You might also have data that's biased toward a particular group, which could lead to a biased model. We often have to apply techniques like imputation, data augmentation, or even data cleaning to handle these issues.
How does data impact the performance of machine learning models?
Data directly impacts model performance. If you have high-quality, representative data, your model can learn complex patterns and make more accurate predictions. Poor data quality means the model will struggle to find patterns, resulting in inaccurate predictions and lower overall performance.
Can you give me an example of how bad data quality can lead to poor model performance?
Absolutely. Think about a spam filter that's trained on emails from the 90s. If we don't update the data with recent emails and patterns of spamming, it won't be effective at detecting modern spam. So, if the data is outdated and not representative, the model's performance will suffer.
What about data privacy and security in machine learning projects? How important is that?
Data privacy and security are crucial. With more data being collected for machine learning, there's also more responsibility to ensure that data is used ethically and securely. It's important to comply with regulations like GDPR, CCPA, and other data protection laws. There are tools and techniques like anonymization and differential privacy that can help in preserving privacy while using data for ML.
How do we balance the trade-off between data privacy and data availability in ML projects?
It's all about context and the specific application of machine learning. Sometimes, anonymized data can be used in place of sensitive data, and you can also use techniques like federated learning, where the data never leaves the device but still contributes to model training.
This has been really eye-opening. So, to summarize, data quality is crucial for machine learning models. It impacts everything from accuracy and performance to privacy and security.
Exactly. Data is the cornerstone of machine learning. The better the data, the better the model will perform. It's not just about having data, it's about understanding what data is, how it's collected, processed, and used in the model training and deployment pipeline.
Thanks for explaining this so clearly. I now understand why data is the backbone of machine learning.
You're welcome. It's a complex topic, but understanding these foundational elements is key to mastering machine learning.